So, Bismillah Rahman Rahim. So, our topic today is three-phase circuits, right? Three-phase circuits. So, let me draw a typical three-phase circuit involving a three-phase voltage source and a three-phase load. So, for example, we have this source here, we have another source here, we have this source here, and for example, these are all connected together like this from their negative terminals, right? These are the negative terminals, and we have a neutral wire also. So this is, for example, A, B, C, and this is small n. On the other side, we have, for example, a load, an impedance. Here also, again, this is a three-phase load. We have three phases, and these are connected together like this, and we have our neutral wire here. So this is A, capital B, capital C, and these are connected together like this. So this is a three-phase, four-wire system. Three-phase, four-wire system. So let's say this is voltage. All the voltage sources are, this is a balanced three-phase voltage source, right? VP angle 0, for example. It has the same magnitude, but a phase angle of 120 degrees, and this is minus 120, sorry, we are assuming a positive sequence, so minus 120. So this is VP angle plus 120 degree here, right? So this is minus 120 degree. And maybe this is load impedance 1, this is load impedance 2, this is load impedance 3, ZL1, ZL2, ZL3. So this is a typical three-phase, four-wire system. And if you look at this, you can draw it in a different way also, in many ways. For example, you can tilt this like this in this direction, and you can tilt this in this direction. And for example, we can draw this load like this also. For example, I'm tilting it like this in counterclockwise direction. So this is plus sign here, this is negative sign here, right? And you see this wire here is the same wire, right? All these terminals are shorted together. So this, for example, can be drawn like this, right? And on top of that, the other source, it can be drawn like that, and then the next pair can be drawn this like this, and this can be all connected together. You see from here, so what I have done is I have just twisted it like this and twisted it like this, and these all terminals are shorted together, right? So this is the same neutral wire here. So for example, this may be terminal, this may be C, and this capital C, this terminal may be B, this may be capital B, and this A and capital A, right? This again is another depiction of the same circuit here. Likewise, I can draw it in another way also, for example, which is most widely used in the books and literature. For example, I can keep this here like this, and I can just take this wire, this source, and put it like this, right here, right? And this here, and I can grab it from here and then switch it here like this. So, for example, another depiction of this circuit will be like this, right? I am keeping it here, but I am taking this, for example, this source here, and just tilting it downwards. So this negative terminals is like this here, and this is positive, and I'm taking this source here and I'm just putting it here, right? So they are all shorted together on the negative terminal side. So this is negative, and just like that, right? And let me call this A, this is B, and this is C, right? And this is then the load side can also be depicted in a similar manner. For example, I can have this load impedance here, and then another one here, and then another one here, like this, right? So let me call this A, capital A, this capital B, and this as capital C. So B connected together like here, and C connected together like here, right? And A connected together like here. So this in effect is the same circuit as this one. All three circuits are the same. So this is a typical three-phase 4-wire system, and this is a YY connection.
सर ये सेकंड से थर्ड सर्कल कैसे बनाया है वो दोबारा बता दें.
Which one? This third circuit or the second circuit?
Yes sir. Third circuit.
Third circuit, right. So for example, I keep it like this in this direction, like, okay, right? I then grab this one, for example, and I move this point here. All these points are shorted together. These are basically this one single point. All these points are this one single point, right? And let me just complete this circuit first, and we have a neutral wire here like this. This is neutral wire, N to capital N. This is N to capital N here, right? So this is all these. This is a single point, so we can squeeze these points together, right?
Third circuit.
Yeah. We are drawing this third circuit from this one, right? So we are squeezing these 3 points together. So these 3 points squeezed together are like this here, right? And these 3 points squeezed together are like this here, right? And then I am just taking this point and then moving it in this way from here, from this direction to here, and this B is then running from here at the top, rather I take it at the bottom, and then this wire runs just like this here, right? And if you straighten out these teeth together, so it will be the same wire here like this one, same circle like this one here, so same circle like this one here. Okay, is that clear with you now, or you still need any further explanation for this?
Yes sir.
All right, so this is a typical three-phase system with the YY connection. So let me explain it for you once more if it's not that much clear with you. What I've done is, starting from this circuit here, you understand this, right? So I have just switched it like this, twisted it like this, and twisted this impedance is like this, and this wire is the same wire running all the way around, right? So this wire is here, all these points is shorted together. So and from this we can modify this circuit to be in this shape. So for example, I keep it this way in this direction, but I grab this wire here and then just bring it down here this way, right? Bring it down this way here. So the terminal, this one, it remains here shorted together with this one, but this terminal comes down here like this, and this wire also comes down here like this here, right? I've just redrawn the wire in this way, and this is the impedance, connected to this, right? Similar way, I've done taken this source and this impedance, this pair, and I have just grabbed this point here and then moved it this way here, and this point is shorted here, right? This is the same point as this one. This point is the same as this one. This point is the same as this point. This point is the same one. So these 3 points are this point here, right? And these 3 points is this point here, right? So I have taken this and brought it here and then connected with is this impedance here, this impedance, this one impedance here. So in this way, I just wanted to let you know that the same circuit is drawn in different ways for the sake of convenience of synthesizing and solving the circuit. So this circuit has 2 parts. One part is the voltage sources part and the other is the impedance part, right? So let's first consider the voltage sources, the source part and the load part, right? So let's consider the voltage sources first. So voltage sources, they have a sequence, right? Phase sequence, particularly if the sources are balanced. By balanced, I mean balanced sources. By balanced sources, I mean that they have the same magnitude. For example, this magnitude VP, VP and VP. They have the same magnitude. Magnitude of all the 3 phases is the same, right? And number 2, they have the same angular frequency, omega. So this angular frequency is the same, so that's why we are representing them in the phasor form in this way. Same omega angular frequency. And number 3, they are out of phase by equal magnitude of phase. For example, 120 degrees. Out of phase, phase difference, or rather phase difference, I should say, phase difference by 120 degree. Okay. So this is for example VP angle 0 degrees. This is then minus 120 degree. It means that VP angle 0 leads this voltage by 120 degrees, and this in turn leads this by 120 degrees. This is VP angle minus 240 or VP angle 140 degrees, is one of the same thing. So in other words, we can say that for example, this is voltage VAN, this source is VAN, and this source is VBN, and this source is VCN, right? So when they are balanced, so then their magnitudes are the same. VAN is equal to VBN is equal to VCN. So their magnitudes are the same, right? And before I show you that VAN plus VBN plus VCN is equal to 0, let me also tell you that we have phase sequences. For example, we have this particular sequence here, phase sequence. Let me first describe what is phase sequence. So phase sequence is the time order in which voltages pass through some typical value, for example the maximum value. It is the time order in which voltages pass through respective maximum values, respective maximum or any typical value, right? So it depends upon the rotation. Phase sequence depends upon the rotation of the generator, right? Rotor of the generator. So for example, we can have a positive phase sequence, and we can have a negative phase sequence. So for example, if we have a positive sequence, in this case the rotor rotates counterclockwise, right? And we have VAN is equal to the VP angle 0 degrees, for example. Then VBN is equal to VP angle minus 120 degrees, right? And then VCN is equal to VP angle minus 240 degrees, and that is basically equal to VP angle plus 120. Minus 240 degrees is the same as plus 120 degrees. So this is the phase sequence. Then if we draw a phasor diagram for this, then for example, if this is VAN, then here we have VBN, and here we have VCN, right? So this is for example VAN, this is VBN, and this is VCN, and you see the phase difference is 120 degrees for them. This is here minus 120 degrees. So if I rotate these phases counterclockwise direction, omega is in this direction, counterclockwise direction. If I rotate these phases in this counterclockwise direction, then watch this point. Here we have VAN, and then we rotate, then next come the VBN, and then if we further rotate, then next come the VCN, right? So this is called ABC sequence also. ABC sequence, first A, then B, then C. VAN, then VBN, then VCN. So ABC sequence also. This is also called ABC sequence. And all these phases are separated by 120 degrees. The phase difference is 120 degrees. Similarly, we have a negative phase sequence. In this case, in the negative phase sequence, we have VAN is equal to VP angle 0 degrees, right? Then VCN, not BN here, VCN is equal to VP angle, the same voltage, minus 120 degrees, and VBN is equal to VP angle minus 240 degrees, or VP angle 120 degrees. So the role of VCN and VPN is swapped, right, in the negative sequence. And for example, if you draw a diagram, we have VAN here, and we have the VCN here. The role is swapped, right? We have VCN here, and we have VBN here now. The positions are swapped. We have VBN here. This is 120 degree.
सर पेज सामने करते नजर नहीं आ रहा.
Okay. 120 degrees, and this is minus 120 degrees. Are you able to see it now? This part that I am discussing, you must be able to see it.
Yes, sir.
Okay.
लेकिन कॉर्नर में है सर.
Okay, and I will switch the page after this. After this topic, I will switch the. I will go to the next page. So these are the three phases now, and if I rotate them counterclockwise, omega is in this direction, for example, angular frequency. If I rotate them, these three phases in the counterclockwise direction, then first at this point I have VAN, then I have VCN, and then comes the VBN. So this is also called ACB sequence, right? Negative phase sequence or ACB sequence. And this is obtained when the rotor rotates clockwise. So this phase sequence is obtained when the rotor rotates clockwise. We get the negative phase sequence, and when the rotor rotates counterclockwise, we get the positive phase sequence, right? Okay. So one more important thing related to the phase sequence. one more important thing related to the phase sequence is that it determines the direction of rotation of a motor. The phase sequence determines the direction of rotation of motor which is connected to the power supply. Direction of rotation determines the direction of rotation of a motor which is connected to a power source or power supply. So that is why when connecting a motor we must choose the sources carefully. So phase sequence carefully. So voltage sources cannot be either Y connected or delta connected, right? The configuration of voltage source, configuration of voltage sources, these can be Y connected or delta connected, right? So for example, this source here is Y connected source, right? So let me redraw both types here for you. For example, we have this VAN, and then we have this here, right, VBN, and then we have here. Note that the negative sign points to this point, the neutral point, right? So this is, for example, VAN, this is VBN, this is VCN, right? So this is point A, this is point B, this is point C, and this is the neutral point. So this is the Y connected source, right? And we have we can have a delta connected source also. This is Y connected source, and we can have a delta connected source. For example, this is one source, and then we have another source here, and then we have another source here. So this is this way. So let me call this as point A, and this is point B, and this is point C. So it is not possible topologically in a delta connected source to have a neutral wire. So there is no neutral wire here. So we have these voltages. This is VAB, because there is no neutral wire, so this is VAB, and this is VBC, B and C, right? And this is point C, right? And this is VCA. So let me at the same time now describe phase voltages and line voltages. Phase voltages and line voltages, right? First look at this Y connected source. We have this source connected between the neutral wire and this point A. So this voltage from A to N, which is VAN, is the phase. Now are you able to?
stream रुक गई है.
No, I think it is reconnected. Are you able to see it now? There was some problem midway, but I think it is connected now. Are you able to see it?
Yes.
Are you able to see it, students?
Yes, sir. अब आ रही है.
All right. So there was a problem. I think I have two connections. One of them goes down sometimes and then try to reconnect with the other.
Yes, sir.
Okay. So if it drops down again, so we can reconnect after some time, right? No problem. So just let me know that it's no more available. All right. So so we can have phase voltages and we can have line voltages, right? And if we are interested in finding the voltage between this point A and the neutral wire N, so then this is the phase voltage of phase A. Then if we are interested in finding the voltage between this line B and the neutral wire N, so this is the phase voltage Bn, the phase of the voltage of the second phase. And then if we are interested in finding the voltage difference between C and N, so this is the phase voltage of the phase C, right? So these are the phase voltages. But what if we are interested in finding the voltage between point A and point B? And then this is the transmission line here, then this is the transmission line here. So these are this is a line to line voltage. VAB is a line to line voltage, right? Or simply we can call it line voltage. Similarly, we may be interested in B, the phase difference between B and C, so that will be VBC. That will be a line voltage, VBC, right? So this is the phase voltage VAN, and VAB is the line voltage. So we can have both the types of voltages when the sources are Y connected. But when the sources are connected in this way, in a delta configuration, then there is no neutral wire. And the phase voltage, right? This is the voltage of this phase. The phase voltage is the same as this line voltage, right? So in delta configuration, the phase voltage is the same as the line voltage, or vice versa. That the line voltage is the same as the phase voltage. But in this case, it's not the same. The phase voltage is not the same as the line voltage. So V line is not equal to V phase. But in this case, V line is equal to V phase in the case of delta configuration. So in this case, we need to find out the relationship between the phase voltage and the line voltage. That we will do shortly, right? Before we do that, let's also consider the load connections. So these were the source connections, configuration of load configuration. So load in a similar way can be Y connected or delta connected, right? It can be Y connected this way, right? And we can have a neutral wire here. This is A, this is B, and this is C, right? And if this is a balanced load, so all the three impedances will be equal, ZY, ZY, and ZY. Most of the times we will be discussing balanced load and balanced sources in this discussion. Similarly, load can be delta connected, right? For example, we can have this configuration, this type of configuration here. Right? So this is, for example, A, this is point B, and this is point C here, right? And this is the balanced, then this is Z delta, this is also Z delta, and this is also Z delta, right? So and if this is balanced load, so then for a balanced load I can write, for a balanced load, Z delta is equal to 3 times ZY, right? Moreover, like we have phase voltage and line voltage in the case of sources, we can have phase currents and line currents in the case of
सर जी फिर से चलेगी स्ट्रीम
are you able to see the stream? I think you must be able to see the stream now, right? Is it there?
Yes.
Okay, good. So what I was telling you is that like we have phase voltages and line voltages, we have phase currents and line currents, right?